Hello class, today we're going to talk about 3.6 difference of squares factoring. So let's begin with refreshing our memories of which factoring techniques we've learned so far. So here's our factoring flowchart. We always start with the greatest common factor first. That should always be your go-to factoring technique. After that, then you're going to look at and ask yourself, how many terms does it have? Does it have 2 terms, 3 terms, or 4 terms? We start off learning factoring on the 4-term expressions by doing factoring by grouping. And then in the 3 terms, you've now learned 3 different types of factoring techniques. The sum product one, where the A value has to equal to 1. We've learned the all-encompassing decomposition technique, which is allowed for when A does not equal to 1. Although, if you want to, you could always use it for A equals 1. And remember, this is the technique you need to know and understand, and you can use it all the time for any 3-term expression. Last class, we also covered perfect squares, which is where the first term and the last term in the expression are perfect squares, meaning they're 1, 4, 9, and so forth. So, like 1 squared gives you 1, or 2 squared gives you 4. And basically, it ends up making 1 bracket squared because it ends up being 2 of the exact same brackets. So decomposition is our main method, but we have shortcut ones where if A equals 1, you can use the sum product, or if you notice that it's a perfect square values on the first and last term and they multiply together and double to the middle term, then you can use those 2 techniques. Today, we're going to now cover the very last factoring technique you need to know for this unit. That's when we have only 2 terms. Now with 2 terms, you could either have it some expression like 9x squared minus 4, or you can have a 9x squared plus 4. Now, a difference of squares is the technique we're going to use. And in the words, you can see that we have the word squares again. So just like the last technique we learned, which is perfect squares, this one only deals with when we have values which are perfect squares. So if you look at the values in the 2 example of the binomials, 9x squared minus 4 and 9x squared plus 4, they're both perfect square values, 9 and 4 are. But the key one that allows us to do a factoring has to only happen when we have a difference, meaning a negative between the 2 terms. So in this example, 9x squared minus 4 is a difference of squares. 9x squared plus 4, this technique will not work for it. Okay, so there are 2 conditions that have to be met for us to be able to apply this factoring technique. 1, the perfect square. 2, the difference. And so we're going to skip through this. So we're just going to write down here the 2 factors necessary for factoring binomials. So binomials mean 2 terms. Is when there is perfect squares and a difference or a subtraction between those perfect square values. So only when these two factors are present can we use this technique, okay? And a reminder, these perfect squares are values such as 1, 4, 9, 16, 25, 36, and etc. Okay? These numbers are acquired when you take the values of 1, you square it, 2 squared, 3 squared, 4 squared, and etc. Okay? So what is this difference of squares factoring? Well, because the 2 values are perfect squares, we could take the square root of the first term and the square root of the second term, and those values end up being in our brackets because the square root of 9x squared is 3x. The square root of 4 is 2. So you just write those 2 values in the 2 brackets. But unlike last time in perfect square, if you remember perfect square technique with the 3-term one, we end up having 2 brackets that were identical. We would end up having 2x plus 3 and 2x plus 3. And so we could just simplify that and write a 2x plus 3 squared. That doesn't happen here because it's a difference of squares. And the only way for us to get a 2 term with 2 brackets is if the middle sign in between those 2 terms are opposites of each other. Okay, so in one bracket, it will be 3x plus 2, and the other bracket will be 3x minus 2. So let's see a few more examples, and that might help you see how this is done. We're going to start off with this one here first. 9x squared minus 25. Now, make sure it meets the criteria. It is a perfect square numbers on both of them, and it's a subtraction or a difference between those two values. So in order for us to do this factoring, I'm going to take the square root of 9x squared and the square root of 25. Well, the square root of 9x is going to be 3x, and I'm going to put that as the beginning term of both brackets. Then the square root of 25 is 5 in both brackets. And then the symbol in between them is going to be a plus and a minus. There are 2 different symbols in between. And that's it. Okay, if you want to try, you could go and expand these 2 brackets, and you'll find out that because those are opposite symbols, the middle terms cancel out. So all you're left with is the first term and the last term. Okay, let's do a few more. Let's go back to this one here, x squared minus 16. You might say, well, 16 is a perfect square. The value of that is 4. So I know that it's going to be 4 as the second term. Then you might say, well, what's the perfect square of this one? Well, it's a 1, and 1 is a perfect square. So I could take the square root of 1x squared. That just gives me an x, right? Or 1x. And so then the 2 symbols are minus and plus. And that's it. I can do it again here, x squared minus 81. So the square root of x squared, or 1x squared, is just x. Then the square root of 81 is 9. And I just put minus and a plus. It doesn't matter which way I go. If I decide to put plus here or minus here, it's the same thing. Then here, 200, it's not a perfect square. But remember that the very, very first factoring technique we should always use is a greatest common factor. If you look at these 2 terms here, we should notice that there's a 2 that can be factored out first. So if I take out that 2, I'm left with, well, 200 divided by 2 gives me 100. I still have my x squared. And then negative 2y to the 4 divided by 2 is a negative 1y to the 4. And then I can now, 100 is a perfect square. So I'm just going to keep the 2 on the outside, and I'm going to factor what's left in the bracket. So if I take the square root of 100x squared, that value will be, I'm just going to put my 2 brackets here. The value of a square root of 100x squared is 10x. So 10x is in both brackets. Then you might say, oh, what's the square root of y to the 4? Remember that when we take the square root of something, we are trying to find 2 numbers that multiply together to give me y to the 4. And it has to be the same 2 numbers. Now, remember, when we multiply variables, we add their exponents. So you could try, well, y to the 1 times y to the 3. Those 2 exponents add up to 4, but they're not the same. Whereas if I had chosen y squared times y squared, it will add up to y to the 4. And what works is the fact that they're identical, which is the purpose of finding the square root. So this is not the answer, it's y squared, okay? So therefore, I'm going to put y squared here and y squared here, and I just do plus and a minus, and now I have my 2 brackets. You okay there? Sometimes you might be able to factor again because you might see that this is a difference, but 10 is not a perfect square, so we will stop there. All right, so just to reiterate what this factoring technique is about. You'll have one term that is a perfect square and a second term that's a perfect square, and there's a minus between the 2. If that happens, I could take the square root of the first term, and that would be the first term in both brackets. I can take the square root of the second term, and that is the value in both brackets at the end. and one bracket's a plus and one bracket's a minus, and that's it. All right, so hopefully that helps you, and I would now like you to try to do these practices, these expressions on the board with your partners and help each other and see if you can understand this difference of square factoring. I have also, if I move this, I've also now, I'm going to distribute to you a bunch of review practice sheets. And you'll see that there's a Unit 3 review, which looks like this, which is a bunch of just clippings from your textbook of different factoring techniques for your quiz, to help you study for your quiz next Wednesday. Now, it's going to be very straightforward. The quiz will just be a bunch of expressions that you need to just factor. And so the key is to remembering what type of factoring technique applies when, and then applying it. No word problems. I also have this other page here for you, which has a series of all different practice problems for you to work on. Greatest common factoring, factor by grouping, the factoring trinomials, which is 3 terms, but the a value or the value in front of the variable squared is just 1. So you can do the sum product. There's one where the a value isn't 1 now, so there's actual values in front of the x squared. The special ones like we've been talking about lately, the perfect squares and the difference of squares. And then here is just a variety of different ones that you can just practice, okay? And the solutions are also in below. Another page I have here for you, it's review activities, which Ms. Trung will now distribute to you, is 2 fun activities you can do that you'll practice factoring, but just not always that straightforward. This one's a maze where you're supposed to start here and try factor, and then the answer is around one of these pathways, and then once you get to that side, you factor this one and the answer is somewhere, and you try to make it all the way to the end. This other one here, the first page looks like a mystery picture. So you're going to color some of these certain colors based on this kind of rubric down here. But how you do it is on the back page of this handout, you have a couple of factoring expressions that you need to do, and whichever one is the answer, those are the ones you're going to use them. So if one of these answer is 3x plus 1, x plus 5, then you have to color every b the color green. And you're going to reveal a nice picture. Okay? So hopefully these activities are fun and gives you something to do to practice and get you ready for the quiz on Wednesday. If you have any questions, let me know, and I will host a math extra help if you like on the Monday night. Okay? Enjoy. Have a great weekend. Bye.